Hello, my name is Jumo Zhang. I'm a student at New York University Tandon Engineering School. So my second author is Royal Shrivel and my professor is Aspen Amstander. Today I'm here to talk about effective mapping schemes of Charmel data stored in relational database. And I'm very glad to give this presentation. And this presentation is for the IEEE conference. So let's get started. I broke my topic into 6 different parts. First, we will talk about the background information, like the goal of our method, and why we choose Charmail, why we choose relational database, and the advantage of them. And then we will talk about the related work, other people's method to map XAML document to relational database. We will talk about like char-rel, char-parent, age, and after we show our hypothesis, I will show my method. You will see the flowchart of my algorithm and the most important part code of my algorithm. And then I will use 5 different XAML documents to test my result, to test my method to get the result. I will show the mapping time of using different method and the database size after we store our XAML document to get the conclusion. So let's get started. Like I said before, many people have different kind of method to map. So our goal is just develop a method to map XAML document to relation the database more effectively. And effectively means we should store the information more quickly, and the database size should be relatively small. After we talk about our goal, I want to talk about why we choose XAML and why we choose relational database. XAML has the advantage of platform independence, self-describing, simplicity, and so on. So it has quickly become the standard of data representation and exchange on the internet. And relational database have the advantages of strong data management capability, high degree of data security, and reliable concurrent size mechanism. Although I learned no SQL in the computer in the cloud computing class, but I think the LDB still has its advantage, and I want to use it. So although XAML and the relational database have those great advantage, however, due to differences in the XAML data model and the relational data model, how to more effectively store and query XAML document in relational database, it has brought many new challenges to the traditional database technology. So that's our goal to develop a method to map our XAML document into relational database more effectively. Maybe we will use a simple structure. Maybe we will develop a new algorithm. Yoshikawa introduced a paste-based approach named Charreal. So, like I said before, the differences in the Charreal data model and the relational data model is the problem. So, according to its tree structure, Yoshikawa divided the Charreal document into nodes and stored in relational tables based on the node type. And Charreal doesn't need any information about DTD and element types, so it's a really simple structure. And Zhang developed a method called CharParents. It's also a model mapping-based approach without DTD, and it can develop a Charreal application that supports multiple Charreal query language and mapping schemes. And the last one we will talk about is the edge. Edge stores the edge of the source and the targets of objects of each edge of the graph and the label of the edge. It's simple, but it will face the self-connection problem when dealing with complicated sorting. So it's useful for simple sorting. So our hypothesis is that we can develop a method which can map Charmail to relational database system effectively. So maybe we use less mapping time and we use a small database size. So we will use 5 different Charmail documents to test the mapping time in relational database. The expected result is that our method uses less time to map Charmail document to relational database compared to the other method we talked about before, like Charreal and CharParent. So let's talk about my method. First, we treat Charmail file as a tree structure. So our goal is to map Charmail to relational database quickly. So we need a simple structure. This we only care about elements, attributes, and nodes. And we use a table I called Charmail table model structure to store Charmail nodes information. So in Charmail table, we can see needs stand for node number, n type for node type, n name for node name, and n value for node value, n path for char path route. And Dewey for Dewey encoding, left Dewey for the Dewey encoding which is closest to left brother node, right Dewey for the Dewey encoding which is closest to right brother node. And in the left part we can see the flowchart of our algorithm. So first we load our Charmail document. Then we get the root of the file. After encoding the Dewey, we write related part into database. Then we handle the left tree node using recursive call. Finally, we write this part into database after encoding it use Dewey. So in this part, the most important one is the parse Charmail, which analyze all the nodes and encode in the Dewey. So we will talk about it later. So here is my parse algorithm part. So the most important one is after we insert attributes into CHAML table and insert the child elements and elements into CHAML table, we use a recursive call, and then we insert the value into the count table. Let's move on to our results. I use, like I said before, I use 5 different CHAML documents to test. I use like a set CHAML, a group CHAML, order CHAML, core CHAML. They have different document size, and I get the time of mapping 5 different CHAML file to my SQL of using 3 different methods: char_rel, char_parents, and my method, and I call it purse here. And from the result, we get the time is not linear with the document size. That's because the records number in database is not linear with the document size. And my method calls the list time compared to the other 2 methods, char_rel and char_parents. In time part, my method can store the CHAML document more quickly. And in table 2 database size, we can see the database size of using 3 different methods: char_rel, char_parents, and my method to map 5 different CHAML documents into relational database. From the result, we get that char_rel and char_parents need more database size than my methods. Because as I said in method part, I treat CHAML file as a tree structure. In order to map CHAML to relational database effectively, I only care about elements, attributes, and nodes. That means I use a simple structure. So char_rel and the char_parents may store more information than my methods. This how to store more information with less time. That still needs more work. CHAML has recently established itself as the standard for representing data in scientific and business applications, and the standard for exchanging data among applications on the web. In this work, we provide a method to map CHAML to relational database systems. And we use a simple structure. We treat CHAML file as a tree structure, and we only care about elements, attributes, and nodes. And then we use a recursive call algorithm called purse CHAML to map. And then we test our method, and we show comparing to char_rel and char_parents. We show that it's impossible to run such algorithm to map CHAML document more effectively. Here's my reference part, and the first one gives the char_rel method, and the second one gives the char_parents method, and the third one gives the edge method. Thank you for listening, and if you have any question, please contact my email jz2730@nyu.edu. I hope my presentation will give you some new ideas, and I'm very glad to give this presentation. So it's my pleasure. Thank you.